Good afternoon to all of you, my dear students. Welcome to Datacom and Network Management Units Lab session. My name is Foad Motalebi. I'll be your lecturer for the lab. Okay, I'm a Cisco certified instructor. In the whole of Curtin, there are two people who are Cisco certified instructor. One is Mr. Viramani, and the second is myself, Foad. As Cisco instructors, what we do is we take you through CCNA modules and teach you CCNA. And if you successfully finish it, you will get a CCNA certificate. Okay. And of course, 50% of your unit's assessment is based on CCNA. Okay. So let's start today's session. Another thing I want to tell you is how I'm going to approach this is, if you look at the CCNA course, especially the latest one, 7.0, it consists of three different levels, CCNA-1, CCNA-2, and CCNA-3. So for Datacom and Network Management, you will do only CCNA-1. At the end, you will go through the assessments, and 50% of your Datacom and Network Management assessment is based on this. And if you successfully finish this, you get a certificate as well, which is CCNA-1 certificate. Now, CCNA-2 and CCNA-3, you will be learning it in distributed networks. Okay. So another thing I want to tell you is how I'm approaching this is I will be going through the lecture slides, 2 lecture slides per week, but not the same. For example, today I started with networking today, but I started it with the morning group. But I'll upload the recording for all of you to watch it as well. Okay. Now with you, I will be doing basic switch and end device configuration. Again, I'll record it and upload it for you to watch, as well as the morning group who have not watched this. Okay. So the lab that you're going to do today is not related actually to this or to this. It will be one step ahead, so that you go back home and do a lot of self-study, and you do a lot of reflection and study, and then come and do the lab. Okay. Today's lab is simple, something very simple, and I will be showing you how to do it. So what you have to do is you have to follow this lecture, which I will upload on Moodle by tonight. Okay. So you have to make sure that you watch all the odd lectures. Okay. Because in your sessions, I will be delivering all the even lectures. Okay. Like 2, 4, 6, 8, and so on. Okay. But you, both the parties won't miss anything because it's recorded and uploaded. It's just a lecture session. You have to go and watch it so you understand it better. Another thing you have to know is your CCNA identity has to be created, and that's what we're going to do today. I'm going to create an identity for you. I've already created a class. As an instructor, I've created a class, and this class is your CCNA identity, whereby you give your username and your email, your name, and then Cisco netacad will send you an email, and using that link, you go to Cisco and give your details and password information, and you can go to Cisco Course 1, Cisco CCNA-1, which is Introduction to Networks, and start doing these modules. These are 17 modules. Okay. So this morning I did networking today. Now I'm going to do basic switch and end device configuration. But the lab which you're going to do today is not going to be based on this or this. It's going to be, there's no lab actually for this week. It's just a basic lab which I've created myself, how to connect two computers. Okay. There's no actual lab as per se in the first week. But I've created a simple task for all of you to do so that you become expert in this. Okay. Now, before I start, do you have any questions? Someone asked if the session is being recorded. Yes, I'm recording it right now. Yes, you need to download the software. Guillen, you need to download the software, but not yet. I'll tell you what software to download. The software that you download, you can download it after I create for you your username, your account on your class in CCNA. Okay? Until then, just be patient. Now, another thing is, of course, your lecture session, what you're studying in your lecture and tutorial is related to Bentley, to Perth. But what you're doing in the lab, the CCNA, is nothing to do with Perth. It's independent, okay? So if you get emails about exams that you have to give, the online exams, don't worry. These online exams are for Perth students because there they have got their own CCNA instructor. Here, your instructor is Foad, which is me. I will set the timing for your test and everything, okay? Because I have the control as an instructor to do that, okay? So every session that we have, every lab session, think of it as a test session, where at the end of the lab, you have to prove to me that you know this skill. I will give you the task, and then you do the skill. For example, next week's lab is going to be basic switch and end device configuration lab, okay? Which you won't be doing today. You're going to go through this recording, okay? You're going to go through this recording and hopefully go through the recording of previous semesters as well. You see, I have over here last semester's recording. You see, I have got last semester's recording. So please go and have a look at these recordings, okay? For last semester, as well as have a look at this semester's recording so that, you know, you become much better in this unit. This unit is actually very interesting, especially the lab component. And mostly been teaching this for the past few years, even the lecture component, but I've got other tasks. So I'm only doing the lab this semester. And usually, not usually, I think every time it's 100% pass rate, especially because of the lab component, okay? Everybody likes the simulation and packet tracer and doing the lab exercises, and they usually score good marks. There are students who can even get 100 out of 100 as long as they follow the instructions, keep on watching the videos, and, you know, do the skill-based exam well, okay? So at the end of this, course, what you will be doing is you'll be having actually two main exams. One is an online exam, objective exam, which you have to answer. And the other one is a tough, maybe if you haven't studied properly, it will be tough, where you have a situation, topology is given to you, and then I'll ask you to solve this. I'll give you 3 hours. I'll say solve it, and then submit your simulation software in form of packet tracer. Now, you have to do this and then immediately upload it. And then I check if everything is okay. If the computers can ping, you pass. Else, we'll see you again next semester. And this, don't worry, this has never happened before. All the students pass because they listen to the instructions, and, you know, networking is usually very interesting. It needs some aptitude, but it's very interesting. Okay. Yeah, but don't download the software from Blackboard. Remember your lab component, when it comes to your lab, forget Blackboard, just follow Foad, because I'm your instructor here. And this instructor, your certificate, the signature on the certificate is Foad signature, nothing to do with Bentley. And the test times that I set will not be exactly following Bentley. We'll be setting the test times independently. Okay. So don't be confused when you get an email from Bentley saying that this time, at this time, until this time, you have got time to finish your test. Okay. Don't click on their link. Okay. Your test links will be under netacad, under my class, which I'm going to add you today. Okay. So because these things get confusing, so you have to be careful. For your lecture, you follow Blackboard as well as Moodle. But for your lab session, only follow Moodle. If you have got some in the Blackboard, if there is a link to some lab sessions that you can download and have a look, you know, they upload some videos, very good. Go and look at those videos. You can get your information from different resources. But when it comes to assessment, lab assessment, follow strictly what I tell you, okay? Because your lab is independent of what they are doing in Bentley. In Bentley, they're also doing CCNA-1. They're doing the same thing, but the instructor is setting their pace, okay? Here, I will be setting your pace, and I'll be telling you what are the chapter exams that you have to give, and so on, okay? So when it comes to lab, yeah, it would be better for you to just follow the Moodle session. Any other questions you have? Okay, we have 32 participants. Is that right? I was told that there was only 27 students. So, okay. Okay. So, once again, this is what we're doing. This is CCNA-1, CCNA-2, CCNA-3. And every level has got a certificate associated with it. Okay? Even that certificate that you get is valuable. Okay? There are people who just have these 3 certificates without a degree, and they go into the job market and get jobs. Okay? So for this course, your certificate will be CCNA-1, consisting of 17 modules. Okay? And CCNA-1 is Introduction to Network. In the morning session, I did networking today, which was a basic introduction. What you have to do is, please, by tonight, I'll upload the video. Please go and have a look at that video. Okay? It's a long session where I talk about different tools and packet tracer and all that. I'll be repeating some things here for your benefit. Okay? And now these students, the 8 a.m. students, they have to watch this video. Okay? If they don't watch this video, then they won't be able to do next week's lab. Okay? So they have some idea. Okay? So next week's lab will be based on this. So again, next week at 8 a.m., I will teach protocol models. Okay? And with you, I will teach physical layer. But don't worry, you're not going to do the lab related to this or to this. Your lab is going to be this one next week. Okay? So all you have to do is a little bit of flip approach where you come a little bit prepared. Okay? Otherwise, not that you won't finish, you will struggle a bit. Okay? Because you will look for information at the last minute and, you know, you get confused and all that. Otherwise, you finish your task very fast and you can leave. And remember, every lab session, including today, there is a task associated with the lab. And you have to do that task. If you cannot do the task within the stipulated 3 hours, then no problem. You can show me next week. But I'm maintaining a record against your name. And I know which student has done which lab. Okay, and if you don't finish, then you show me next week. Okay, let's start. So I'm going to start with module 2, which shows you the components of a network. One of the main components is a switch. Okay. A switch is used to connect IP devices together, especially computers. Okay. You connect them by using your cables. Okay, so we are going to go through basic switch and end device configuration. So try and pay attention, and then later go and watch the video of module 1 and module 2 as well. Okay, by the way, whatever things that I'm telling in these lecture slides, they are all on netacad in detailed format. You don't have access to netacad yet. I'm going to create access for you after this lecture. Once I create an access for you, then you can, in your own time, go through netacad, where the information given will be much more exhausting, much more comprehensive than these slides. Okay, but again, you can go through these slides whenever you're free. There's a question. So 8 a.m. students have to watch 1 p.m. video, and 1 p.m. students have to watch 8 a.m. Yes, you got the gist of it. I couldn't have said it better. Thank you very much. Yes, the more videos you watch, the better. But remember, both 8 a.m. and 1 p.m. students have to do the same lab. Okay, like 8 a.m. students have already finished that lab, and now you would be doing the same lab. What is that lab? I'll show you. Okay, so let's go through this topic. In this topic, we'll be actually showing you the Cisco devices, the networking devices, be it a router, be it a switch, be it any other intermediary device. All these devices, they have a special, okay, they have a special operating system, internetworking operating system. Okay. Now I'm going to repeat a few things because you guys are new. A switch is used to connect all the computers in the same network. Okay. We'll be looking at a picture of a switch very soon. A router, on the other hand, is used to connect different networks. Okay. What do I mean by different networks? I mean the IP addresses are different. So a router can connect two different networks to each other. A switch connects the same network to each other. So today we are concentrating on the switch. But both the switch and the router have got this IOS. Okay, this IOS that we're talking about is a operating system for both the switch and the router. And this unit is all about programming your switch and your router based on the commands. And these commands, my dear students, you have to learn. That's the main task. Okay. So we'll be going through some iOS navigation commands. We'll look at the command structure. We'll look at basic device configuration. We will learn how to save configuration, what are the ports and their addresses, and we'll configure IP addressing and we'll verify connectivity as far as the switch device is concerned. Using a software, because we're not in a campus now, we are not going to use the actual device since we are in a pandemic situation and, online mode. We'll be using a software known as Packet Tracer. It's a simulation software in which you can learn programming, you can learn how to program your iOS devices and how to configure them. The more you use this simulation software, the better you get at networking. Okay, and believe me, it's a very rewarding career, and if you get good at it, you earn good money. There's one topic over here. It says verify connectivity. How? By giving the command ping. Okay, when you ping, which I'm going to show you later, if the ping is successful, that means the connection exists. If the ping is not successful, that means the connection is not there. Okay. So let's talk about the Cisco iOS operating system. So every computer system, operating system, has got a shell, a kernel, and a hardware. Okay, the shell communicates with the kernel, communicates with the hardware, and so on. The same goes with Cisco internetworking devices, your switches and your routers. Once again, what is the use of a switch? A switch is used to connect devices belonging to the same network. What is a router? A router is a device which connects to different networks. Okay, I'll be repeating this, okay, until you all get expert in networking. So similarly, just like Windows is an operating system, Linux is an operating system, they have a shell, a kernel. So does your iOS, Internetworking Operating System. Now, unfortunately, your Internetworking Operating System is a character user interface. Okay, it's not a graphical user interface. So you have to learn commands. Okay, you have to learn how to give those commands by remembering them. Okay, as much as you can. So in order to run those commands, you need a keyboard. Okay, you need a monitor so that you can connect your switch or your router to that monitor, or to that computer rather, because the computer has got its own monitor and a keyboard. Once you do the connection between the computer and the switch, or the computer and the router, now you can see the output on a computer, and you can start typing out the commands by using the keyboard. Okay. So this is one way to access by using a console cable. You see this? This is a console cable. What we do in this cable, we connect one end to the switch, and the other end we connect to our computer's COM port. Okay? Sorry. Once you do that, my dear students, once you connect it, now by using a software like Telnet or PuTTY, what you can do is give the IP address and the port, and now you can see your switch or your router configuration over here. So your iOS will load over here and you can see it. Okay, that's very easy. That's it. Use this cable and connect your switch or your router to your computer. Now there will be a window on your computer which is loading your router or switch inter-network operating system. So you can start programming it. You can start giving commands. Okay? Maybe programming is not a right word to use. Okay? What you would be doing is setting and configuring your switch or your router. So the software that we use usually is PuTTY, or we can also use Telnet. Okay. All you have to do is give your host name and the port number. Okay. And if you're using your COM port, a serial port, then you can connect. Sometimes you want to connect through the network also. If you have got a network connection, you can also do that. Okay. Now let's look at the actual operating system, how it looks, and how do you navigate. When you open the connection, when you establish a connection, and when your internetworking operating system loads for the first time, this is what you will see for a router, and this is what you will see for a switch. Now I'm going to do a packet tracer simulation for you. Observe. I'm going to open my packet tracer. This is the software that you're going to install on your computer today. The first time when you run your packet tracer, you have to give your netacad username and password, which you don't have yet, but I'm going to create for you today later. So you can see this is my Cisco packet tracer. In the Cisco packet tracer, what I'm going to do is I'm going to go and look, these are the routers that we have, different kind of routers. And this is the switch. Okay, so I take a switch and I put it here. Okay, so I have a switch. Now, when you open your switch for the first time, okay, what you do when you open it, you can see your switch over here. This is a basic 2960 switch consisting of 24 ports. You can see that means you can connect 24 computers to this, okay, and create a basic network. Now, if you see, there is one tab known as CLI, Command Line Interface. If you click here, you will see that your switch is loading, okay? Press enter. There. You can see my switch is already loaded, okay? Now, if you go back to the slide, when you are seeing the first prompt, this is known as user exec mode, okay? Now, in the user exec mode, you cannot do much, okay? You cannot do many things. In order to go to a privilege mode, okay, privilege exec mode, which is the name of your switch or the name of your router and then a hash, you have to type enable, okay? You have to type enable. You see, now I'm in the privilege mode. If I want to get out of the privilege mode, I type exit. There, I come out. If I want to go back to privilege mode, I type enable, or I can just type a short form, EN. Okay, there. So this is what you can do in order to gain access to the privilege mode on your switch. Okay, so the moment you see this, you know that you're in the user mode. The moment you see a hash, you know that you are in a privilege mode. You can also give configurations, okay? In order to go to a configuration mode, okay, then you have to type something known as configure terminal. Okay, these are some basic commands, my dear students, that perhaps you have got 1 week to prepare until next week, okay, before you do your lab. So I type configure terminal, okay. See, I go inside configuration mode. If I want to get out of here, I type exit again. Now, just like a short form for enable is EN, for configure terminal also we have a short form. See, conf T. There, same thing. Okay, now I can go to my switch and change the name. Okay, for example, I can say, I have got a student here, Adam in Bayan. I can say, perhaps host name Adam switch. Okay. Look, the name of my switch has changed to Adam switch. Okay. The switch that I had here, okay, has changed into Adam switch. Now, it doesn't show outwardly. If you want to change it outwardly over here, okay, then you can change the name. Wait a second. You can change the name over here. Switch 1. Okay. So now it is switch 1. But inside, CLI, if you go to your CLI, you can see that I have written over here, Adam switch. So anyone accessing this switch, it will show the configuration as Adam switch. Even if I exit and go into privilege mode, it's still Adam switch. Okay. So you can make these changes by using a host name, command, and so on. Okay. Another thing you should remember, the name that you get over here is not the name that is shown to you in packet tracer. You can change this name. If you want this also to be Adam switch, then you have to type it over here. Okay. The packet tracer software that you're going to download from netacad today should be the latest one. The latest one, okay? Even the one I'm using over here is not the latest, but the one which you are going to download will be more updated, more latest than this, what I'm using over here, okay? So let's go back to the lesson. So we also have a line configuration mode. If you are trying to create an IP address on an interface, then you go to line configuration mode and so on. Line configuration mode is when you want to configure a console or telnet or SSH. If you want to configure a port, a router interface, or a switch port, then you have to go to this interface. Okay. Don't worry, you'll learn all these things slowly. So we have got the privilege exec mode, we have got the global configuration mode, and we have got the line configuration mode. Okay, we'll get used to these slowly. If you want to give major commands, then you have to go inside your configuration, global configuration mode. Okay. You can also move back by typing exit like I did. Okay. If I'm inside here, if I want to go one step back, I just go back to my user mode and just type exit. Enable conf t. Exit. Exit. And so on. Okay. Very straightforward, very simple as far as your switch is concerned. Okay. Now, these are some commands that you have to be familiar with. Today, I'm just teaching you two simple ones, enable and conf t. That's it. Okay. Now, for example, if you want to give a interface command, you just type your interface fast Ethernet 01. If you go to your switch, see, if you look at your switch, sorry, please bear with me. I had a picture of the switch, right? Okay, I can't find it. Let's move on. So anyway, if you want to, okay, let's look at a picture over here. Look, if you look at your picture of your switch, okay, uh, this configuration that you have over here, okay, every interface that you have, you see, in my command structure, it says interface fast Ethernet 01. Fast Ethernet 01 is this one, 01, 02, 03, 04, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24 ports. And you can actually call any of these interfaces and do any configurations. Here, I'm calling interface fast Ethernet 01. So I'm calling this interface, okay? So all the odd ones will be down and all the even ones will be up, okay? Depends on which make of the switch you are using, okay? So you can given configure every interface, okay? Now, usually, rather than taking every single interface and configuring it, we can create a VLAN on the switch, and that VLAN will encompass all the interfaces. You can do that as well. Okay. In fact, that is the lab that you're going to do next week. If you look at your iOS command structure, okay, uh, you have got the prompt first, then you have got the command, then you have to mention a space, and then you mention the keyword. For example, ping to establish an eco connection, a network connection, whereby you get a reply from a distant device. If you get a reply, that means the network is connected. Okay. If you don't, then that means there is no connection. So every command structure consists of a prompt and the actual command. And then you put a space and then you type another keyword. Okay. A command might require one or more arguments. So it depends of what commands that you have. Okay. Italic or boldface, they have got a special meaning. Okay. So boldface text indicates commands and keywords that are entered as shown, and italic text indicates an argument for which the user provides a value. Okay. There are so many commands, my dear students, that iOS has. And you know, when you do CCNA-1, you're not going to be exposed to all these commands. But by the time you finish with CCNA-3, you will know almost all the commands. Okay. Here, ping, give the IP address, or trace route, give the IP address. Okay. Put a space and give the IP address. If you look at the command that I gave over here, my CLI, when I changed to Adam switch, you see what I did? If you can scroll up, you can see, yeah, host name, space, I have a space here, and then Adam switch. Okay. So you can do that as well. Sometimes when you're not sure about a command, what you can do is you can just type the command name and then put a space and a question mark, and then it gives you more information about it. Okay. And if you make a mistake in typing your command, your internet working operating system will not accept it. It will say invalid input detected. Okay. And then you have to correct it. Now, you don't have to type. Even in packet tracer, you see, I'm not going to type. I just use the up arrow key and it has the history of all my commands. For example, I type enable. Now, when I go to the up arrow key, you see, all the history of my previous commands can be shown. Okay. So if I type conf t, so conf, all the history of my commands would be able. Now I'm in a new configuration, so it won't show me. But if I go back to the old one, then it will show me all the history of the command. So sometimes you don't even have to type. Okay. You just use the up arrow key and you get your previous commands. So you have got hotkeys as I showed you. Instead of typing enable, you just type en. Instead of typing configure terminal, you just type conf t. So these are called hotkeys. Okay. Sometimes you can use, certain keystrokes to enhance your command line editing. Those could be tabs, backspace, left arrow, right arrow, or up arrow to show the history of your commands. Okay. Now, these things are actually child's play, but because when you start using Packet Tracer, the simulation software, it's actually like playing a game. But instead of just doing a meaningless game, you are learning networking, and it's very interesting. It's very sweet. Knowledge is sweet. Okay. And if you want to learn networking, do more of Packet Tracer. Okay. Sometimes a command may produce more text that you can read. Okay. In those situations, you will get, just like a disk operating system, you get more. And then you have to keep on clicking on any keystroke, so you get the next page of information. Okay. So when you enter key, displays the next line, spacebar displays the next screen. So these are some things that you have to get used to. Okay. Control C, when in any configuration mode, ends the configuration and returns to privilege exec. Control Z, Control C, Control Z. When you're in any configuration mode, ends the configuration and returns to privilege exec mode. Okay, Control Shift 6. So this is an all-purpose break sequence used to abort DNS lockups, trace routes, pings, etc. Okay. So any ping that you're not getting a reply and want to get out of it, just press Control Shift 6. So these are some things that you can practice, make your work faster. Now let's go to our basic device configuration. When we talk about devices, remember the two most important devices that we have in networking are our switches, which is used to connect the computers to the same network. What's the meaning of same network? That means all have the same IP address, same range. Another another device is a router. A router, on the other hand, is used to connect two different networks together. What is the meaning of different network? That means one network has got a different IP address, another network has got a different IP address. Okay? One has got one range and the other one has got another range. If the range is different, they cannot ping each other. That is why you need a special intermediary device known as a router. Okay? I'm repeating certain things because it's important. So this is a basic configuration where you can change the host name. And you can see that I've already changed my host name to Adam's switch. Okay. So this switch that I have over here is not mine anymore. It belongs to Adam. Okay. Usually, as a network administrator, what you are going to do is whatever switches you have, you're going to give a proper name to it. For example, this is in engineering building, level 1, room 24, something like that. Okay. So labeling and giving a proper name is very important, especially if you are the network administrator and the whole enterprise network rests on your shoulders. You know, you may have emergency, something goes wrong. They will be calling you to come to the campus at odd hours and fix stuff because, you know, people cannot access Moodle or any other reason. Okay. So the job is actually very rewarding, but at the same time, a little bit intensive and tense, maybe in the beginning, but as you go along, the experience that you gain, you become better at it. So when you give a password, it's, you know, when you give an access password to your switch or to your router, it's always good to give a good password, you know, especially when you're working as a network administrator. You don't want anyone to access your resources except your immediate underlings who you trust. Okay. But when it comes to giving passwords inside your uh, packet tracer, I would encourage you when you do your labs, please do not give any passwords. Okay. Even when we are in the actual lab, I always tell my students, do not give any passwords for your actual equipment, your switches and your routers. And if you have to give a password, then please only give 2 passwords, either Cisco or class, lowercase. Okay, either Cisco or class. That's it. So in order to access the user mode, you can set a password. Okay, what you can do is you can say configure terminal. Okay, then you can say line console 0 password Cisco. Okay, login and that's it. So next time when you're logging to your system, okay, when you open your system, and it will ask you for a password, and then you have to type the password Cisco. Okay. You can give another password whenever you want to go from user mode to privilege mode. Then you can say enable secret. Now you see class. Okay. So I can set passwords like this. So you can practice this. But when you're doing your lab, usually in the lab exercise, instructions will be given. Give a console password, give a secret password. Just ignore that, okay? Because that is another headache for the person who checks it. You just do this once, practice it on Packet Tracer, and then you're ready to go, okay? So here is my switch. I go to my switch, okay? So, sorry. So let's say I'm right over here. Okay, so I type line console 0. Okay, there I'm in line, and then I say password. I always stick to Cisco, and I always in the lab, all students, you know, they either give a password Cisco or class if they have to give password. Okay. Okay, now I exit. There, user access verification. Can you see? No matter what I do, it will ask me for user access password. And I type Cisco. Now here, there is another level of security. When you type, you cannot see your keystroke. I type Cisco, press enter. Now I can go in. Okay. Now when I type enable, I go in. But what if for enable also, I want another level of security? Then I have to give my secret password. You see what I do over here? I go here and I type enable secret. Password is class. Okay. Exit. Exit. So if I want to go into user mode, my password is Cisco. Now, if I type enable, you see what happens? It's asking me for privilege password as well. What was my privilege password? Class. CLASS. Now I can go in. Okay. 2-level security, my dear students. Okay. Please practice this once and be done with it. Don't do it anymore in your labs. Okay. Until the final exam. Final exam, if we ask you to do it, please do it. Okay. Your final skill-based exam. But every lab, every week, if you keep giving the password for both your line as well as your secret, please, you will just wasting time. Okay. So please enjoy this once on your packet tracer and be done with it. Okay. Thank you very much. Now, you can also give a line VTY password. Okay. This enables you to access through the network. Sometimes you don't want to physically connect to the router or to the switch, but you want to access it from the network. So if somebody is accessing from the network, you can give the line VTY015 password. So that means when they're accessing from the network, again, there will be another password associated with it. Okay. You can also encrypt your password so that it cannot be seen. Okay. So you can say service password encryption. That's it. Okay. Every time you make changes to your router or to your switch, those configurations can be saved. Okay. So when you start your switch, the iOS, you can see your beginning configuration. You can say show startup configuration. It will show you the startup configuration. You can also say show running configuration. If you have made any changes, it will show you the running configuration. Okay. Now you can change and say that I want my running configuration to be my starting configuration. Okay. You can also erase your startup configuration. Okay. You can do all, because whatever changes you made, when you restart your router or your switch, those changes will not be implemented unless you copy your running configuration to your starting configuration. The command is copy running config space startup config. Once you do that, then the changes on your switch will be finalized. Okay. The same goes for router. If you want to erase your startup configuration, just type erase startup config and everything is removed. Okay. Sometimes what students do in the lab when they use the real equipment, they do not, they copy their running configuration to startup configuration. So when the next group of students, they come to the lab and use the switch, the IP address is already there. Everything is there. Okay. And then what happens is that student doesn't, sometimes the student is confused, doesn't know what's going on. And sometimes the student doesn't have to do anything because the configuration is already done by the morning class. All they have to do is connect the wires and they say, sir, done. And actually they haven't done anything. So it is sometimes what we do is in the lab, I give instructions to the person in the lab that make sure you erase all the running configurations, okay? Because when you tell the students, don't save your running configuration as your startup configuration, sometimes they don't listen. You know, they want to try out the commands and they mess up the system. Okay. You can also, whatever changes you have made, whatever commands you have typed, you can save it into a text file, okay? By using your PuTTY or any other software like TerraTerm. Yeah, saving all your changes to your text file. These are the steps which you can follow. In case of packet tracer, you don't have to worry about that because the history of your command is all given over here. But if you're using the real equipment, then you have to worry. If you want it to be saved in a notepad file, in a text file, then you follow these steps. Okay, now let's go to ports and addresses. Okay. Now, if you have a computer has got an IP address. Okay. So today's task, my dear student, what you have to do, okay, what the morning students did is take a computer, you see, a normal PC and another normal PC, okay, and connect them to each other. That's it. Your task for today. Use a cable, okay. We cannot use a straight through cable to connect two PCs together. They will not communicate. You see, if I use a straight through and connect it to this, you see, you get the triangles which are red. It won't work, okay? Rather, you have to use a crossover. Crossover means the arrangement of the wires, 8 wires on this end and the other end, the arrangement is not the same. It's different. Now you see? Green. Okay? So anyway, I'll show you this again later when you have your packet tracer. Okay? So anyway, once you have your computer, this is how you set your IP address. Okay? Now, IP address consists of 4 octets. Okay? And these 4 octets define the logical address of your machine, of your computer. And you also have a subnet mask. The subnet mask tells you how many portions of your address is network-based and how many portion is host-based. For example, here, when you see 255, that means it is 8 ones. Okay, why don't you just convert, use your calculator and convert 255 into binary format. Okay, let's open our calculator. Okay, so in decimal, I type 255. So 255 in binary is 1111111. Okay, so if I have 255 plus 255 plus 255, so that means 8 plus 8 plus 8. So that means 24 bits are for the network. The moment you see ones, that means network bit. The moment you see 0, that means host bit. Okay, so if I type here 0, okay, for decimal, if I type 0, that means 8 bits of 0. That means in this network, we have got 8 bits for the host and 24 bits for the network. That is what we have subnet mask for. Okay, if you don't understand this right now, my dear students, don't worry. Don't feel bad. Okay, you will be learning, you'll be expert by the end of this semester, I promise you. Okay, it's just an introduction. Okay, anyway, so what does this mean is, in this network, that means all the PCs in this network, you will only change this value. That means it starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 254 is the last number. Okay? It can't be 255 because 255 is registered for something called broadcast. Okay, we'll study that. But anyway, you just remember that the host portion can only be changed. Okay? So every device has got an IP address. Okay? And the subnet mask tells you which you have to change. The host portion is 8 bits, so you have to change only this. The default gateway is the connection to the router, so the IP address of the router has to be mentioned. Okay? Another thing you should know, this is an IP version 4 address, okay, consisting of 4 octets. We also have IP version 6. This is a 32-bit address, 8 plus 8 plus 8 plus 8. That will be 32 bits. In this situation, because of the subnet mask, we know 24 bits is network, 8 bits is host. But in a IP version 6, we have got a 64-bit address. Okay, now you may ask, what is this IP version 4 and IP version 6 address? I'll tell you what it is. The situation is such that we have got so many devices, so many IoT devices, so many network devices, that IP version 4 is not enough. We need a new technology, and that one is IP version 6. Now you may ask, in that case, why am I learning IP version 4? I just want to learn IP version 6. No, not so soon. You can still use IP version 4 inside your LAN, local area network. Okay? But if you want to make it in a public domain on the internet, then it has to be IP version 6, because we are running out of IP version 4 addresses in the public domain. Okay? That is why you have to know both IP version 4 addressing and IP version 6 addressing. Okay? Some concepts like subnetting is a bit tricky. That is why you have an instructor to help you to understand, so you do the calculations properly, and then you can pass your exam. Okay? So the single complicated thing in CCNA1 is this, my dear students, IP version 4 addressing. Okay? Once you understand this, everything else is okay. And don't worry, I will teach you and make you expert. So over here, you can see a switch. Okay? Look, over here is a 24-port switch. Now look at this switch over here. Look how many ports it has. Okay? So you have got different kinds of interfaces. You have got a wireless, you have got your different kinds of cable, you have got a UTP cable. It can be STP or UTP. Okay, this is the industry standard. This morning I was telling the students we had this UTP cable come out in the 80s, and until today, it is the industry standard. No building is built without taking into consideration the wiring for this. Okay. This is your fiber optic cables, and here are some of your wireless media. So how do we configure IP addresses? By using our internetworking operating system. Very simple. For a PC, what we can do is we go to our control panel, we go to Network Sharing Center, and we change the adapter settings. And then we give the IP address. Okay. If we are giving a static IP address, then we type the IP address. Else, we can say obtain an IP address automatically. Sometimes we have got a server called the DHCP server, Dynamic Host Configuration Protocol. This server has got one task. It gives IP addresses to all the devices in the same network. Now, this can be a computer. You can have a DHCP server as a computer, or you can have a router do this. Yes, a router can give IP addresses automatically. Usually that's how it's done. And you'll be learning how to do this as well. Okay. Perhaps not in CCNA-1, but in CCNA-2. Okay. So anyway, when you select obtain an IP address automatically, your computer will be looking for a DHCP server in the network. If the DHCP server is your router, it will get the IP address from the router. Here, you can give an IP address to your switch. Okay. So I say configure terminal, then I say interface VLAN 1. And then I give an IP address to my VLAN 1. Okay. Remember I told you over here. Yeah. Over here. Okay. If you look at the physical ports that I have, I use one VLAN and I give one address, and that VLAN encompasses all the ports. Okay. So using that, I can give an IP address. And once I give an IP address, I type no shut or no shutdown. What does this mean? That means enable this virtual interface. Okay. I don't have to restart it. So enable this virtual interface. So immediately the IP address will be enabled on the switch. Okay. So this brings us to the end of today's session. Okay. Now let's go to your task for today. Your task for today is very simple. Your task for today is this. Please pay attention. Your task for today is make a simple peer-to-peer network. Get a computer, PC, like I'm doing here, another computer, PC, like I'm doing here, and create a simple peer-to-peer network by taking, remember, you cannot use a straight through. In straight through cable, both the sections, both the ends, the wires are arranged in the same way. Okay. So when you're connecting two computers together, it cannot be a straight through cable. Okay. It has to be a crossover cable. Okay. You will learn how the wires are arranged in straight through and how the wires are arranged in crossover. Okay. We'll be showing you that as well. So don't worry. So anyway, this is a straight through. You see, when you put your mouse on it, it tells you copper straight through. Right here, it tells you. When you put your mouse, hover your mouse on top, it says copper crossover. So go to a crossover cable and connect to your fast Ethernet 0 on your PC. This is your network interface card. And the PC to fast Ethernet. Okay, so now I have got two PCs over here. So this can be confusing. I say PC A, PC A and PC B. Okay. I can even type my IP address over here. Right here, I say PCA IP address is 192.168.1.1. Okay. This is my IP address, which I'm going to give. Okay. This is just a label, my dear students. IP address is not given yet. I have to go and give the IP address. So this is the task you're going to do today. So 192.168.1.2. So this would be the same network, you see. This is 1 and this is 2. So the host portion. So what will be the subnet mask for this? It will be 255.255.255.0. Okay. So how do I set the IP address? Very simple. Go to your PC, go to your desktop, go to your IP configuration, and give a static IP address. There we go. 192.168.1.1. Subnet mask, just click here. It comes in automatically. You don't need to give a default gateway because there is no router in this topology. Just two PCs being connected to each other. That's it. Once you're done with it, you close it. Then do the same for your PCB. Go here, go to your desktop, go to your IP configuration, the same thing, 192.168.1. You cannot say 1 anymore because that is the IP address of PCA. You have to say 2. Or anything from 2 to 254. Subnet mask, again, you don't have to type, just click on it. The system is smart. It knows that it is 24 bits network portion and 8 bits host portion. That is what the subnet mask means. Okay, so that's it. Now you have a physical network and you also have a logical network. Is there a connection? Let's have a look. What I do is I open my PCA, I go to my command prompt, and in the command prompt, what I do is first I ping myself to make sure my TCP/IP is working. Okay, here, have a look. Okay, ping my own computer 192.168.1.1. Okay, so let's ping and see whether it works. I'm pinging myself. Yes, you get 4 replies. That means the connection is okay. So no problem. So what I do is I now ping my PCB. So I type 2. There, you can ping. That means the network connection is perfect. Now I'm going to do the same thing from here. Okay. Command prompt. Okay. Ping PCA. Ping 192.168.1.1. Yes, it works. The network is working. Okay. So this is your task for today. You have to show me this. But first, what we have to do is we have to first go and create an account for you on netacad. So I'm going to stop the recording now. Yes, GN is saying, can you show unsuccessful ping? Yeah, sure, I can. Here, command prompt. I'm going to show you an unsuccessful ping. Look, you know that you have got how many devices over here? You have got 2 devices, correct? PCA and PCB. Now, let's say I want to ping to a device that does not exist. Let's say 23. Do we have an IP address of 23? There. It's trying to find the device 23. There, it cannot find it. Request timed out once, twice, 3rd time, 4th time. That's it. This is your unsuccessful ping. Okay. Yeah. So simple. Okay. Now I'm going to stop the recording. A very good question. Taufik says, how do we submit the task? What you do is you share your computer. You don't submit it. You share your computer. You share your packet tracer, not your packet tracer, your whole screen because some sections of the packet tracer will not be seen otherwise. You share your screen and then you ping in front of me and then it will be accepted. But not yet. First things first. First, let's go. Let me stop my recording.